So I'm part academic, so I'm a senior stats lecturer down at Newcastle, so I'm one of the very few people who moved there for the weather. If you've only lived in Glasgow, it rains all the time here. You know, it's just miserable most of the year round. Whereas in Newcastle, we didn't have snow this year. It's great. It doesn't rain. So Newcastle's great for the weather. It's sort of like the Mediterranean, a few degrees cooler. Similar dress sense as people in Glasgow. You know, they don't believe in jumpers or jackets or anything like that. So I did a BSc PhD at Strathclyde, so at the turn of the century. I was looking through the staff list when I was coming up here. It's quite depressing how few people you know. So I know Anne over in the office, and that's pretty much it. A year ago we set up this company, Jumping Rivers, and I apologise for using the word data science at RSS. People just understand that it's a bit more sexy, and people are willing to give you money to use data science rather than statistics. And we do things like training in R, Stan and Scala. And what's quite nice is R seems to be a language that's just exploded. Right? You know, lots of things you do at university, and lots of things that we force on students, undergraduates and PhD students, don't really get used in the real world. Whereas R just seems to have taken off, and lots of businesses, banks, building societies, NHS, Ministry of Defence, the law, everyone just seems to be jumping in this programming language. So it's quite good fun of being part academic and part consultant, dealing with real data and real people. So, as with all things, you get an email, you're given a suggested talk title, and because it's 6 months ago, you go, sure, of course, and then it comes to actually writing said talk, and you think, why enough did I agree to this? So the talk will occasionally veer off topic, so sorry about that, but I will keep going back to CRAN. But yeah, you agree to these things so many months in advance. So a brief history of R. So in case you don't know, R is a programming language, and it started in 1993 in a research project in Auckland, New Zealand. The first version was released in 1995, so released an open source project, open source software. And in 1997, 20 years ago, our core group was formed. I find this quite amusing. The mailing list was formed on April the 1st. If you were used to the mailing list, it's particularly amusing. And CRAN was started, so that's the thing we'll talk about, and it's 3 mirrors. So a mirror is just essentially an identical copy of the website throughout the world. Now there's around about 100, now there's around about 140 mirrors. That's slightly misleading because that's double counting of HTTP and HTTPS. There's around about sort of 70 mirrors you can think of. And in 2000, I started using R around this time. And would you believe, when I left this department 15 years ago, I got a CD, or a DVD or a CD with all my stuff from my PhD, and it's still, you know, copied that onto my hard drive at work, and it's still there /Colin G. And so I had a little look through this stuff, and I've got an amazingly named file called commands, no file extension, it's just commands, and I've got this line in s+like package R, and in case I forgot how to start it, I've got the word R, just so it's clear in my mind. And this was round about, was this 2000? And then I thought, well, actually, I'll do a little bit of digging and see what R scripts I've got kicking about. So my PhD was stochastic processes, so I did a bit of programming in a wonderful language called Fortran 77. It's probably still used by some people in this room. And I did a little bit of R for graphics. And so this is one of my first R graphs of October 26, 2000. So this is the code copy and pasting. I wasn't quite sure about the proper way of doing file paths. I've got little pluses. I've got extension .out, I have no idea why, because it was an output file, so why not? I didn't know about read.csv, so I'm using scan. Perhaps the most interesting and surprising thing to people might be, if you notice I've got A_scan and Z_matrix in the first and second line. So when I was first released, you used to be able to do a sign-in using the underscore. Of course, it wasn't consistent in any way, shape or form, so it just randomly changed because I didn't quite understand what was going on. So yeah, that's the first thing. And what's amazing is this still works. I'll need to change the underscores to an equals or an arrows, but I've still got the original data and I can still generate a plot from my PhD 15 years ago. And if you've ever worked with other disciplines and asked them to generate a plot from their paper 6 months ago, I realise that this is quite impressive. So the reason why I know it was October the 26th was I actually used the mailing list. I didn't realise how brave that was then, just the foolishness of youth. It was an okay question, so that's a link to the question, so when you get the slides you can see the original question on its glory. Purse plot question, not the best title. I think I was quite lucky to walk away unscathed. But it was an okay question. And Ross Ithaca answered it. He was one of the founders of R. And again, I was completely oblivious to the fact that there's this guy in New Zealand who's just developed this R piece of software who answered my question pretty quickly. In case you're wondering, this is what they produced. This was the pride and joy of my thesis, this one graph. And this is why it passed the Viva, because of that one graph. But yeah. So, 2003 our foundation was founded, 2000 our 1.0 was released, 2003 our foundation, version 2 in 2004, version 3 about 10 years later. Okay, so that's a brief history of R. But what's CRAN? Right? That's sort of an interesting question of what's CRAN. We're celebrating, odd if you think about it, we're celebrating what CRAN, 20 years of CRAN is, but what is it? Well, unlike when I did my degree, Wikipedia is now here to help answer this question. And so when you Google CRAN and Wikipedia, you come up with 4 possibilities. And the top 3 are a bit dull, but the bottom one is great. So CRAN is a measurement of unclaimed herring. And I'm thinking with Brexit we can get these units back to the sort of forefront of the national consciousness, so we can start measuring unclaimed herring. It seemed to fall out of fashion around about the 19th century, but there's always hope. So the third one, CRAN R programming language, a package archive network for the R programming language. If you go to their website, CRAN is a network of FTP web servers around the world that stores up-to-date, identical versions of code and documentation. Okay, so it's getting a bit more clear. So it's essentially a big website filled with stuff. Basically a collection of R packages for the most. That's what we think of CRAN as. You think of CRAN as where you get the packages. Okay? And the growth in our packages is just absolutely phenomenal. Right, so on the x-axis going along, we've got time. So in the faraway corner, we're starting off at around about 2005, 2004. Here, that dot was added in the last 24 hours. And in the last 10, 12 years, we're now over 10,000 separate R packages. And that's really quite astounding. Right? There's over 10,000 packages on CRAN that we can download and install. And they just cover everything. Again, sort of preaching to the converted, they cover all sorts of things. And it's quite astounding. This free bit of software developed over 20 years ago is now just sort of caught on and it's growing, sort of in a quadratic rate. What is an R package? So how many people have actually written an R package and put it in CRAN? Is anyone brave enough? So we've got a couple of people. Right? So I don't know. Again, I apologise if this is all blatantly obvious and you're all expert package office, but I thought you might not really know what an R package is. Right? Install it, download it. What is it? It's just a tar file or a zip file. It's just some code. And it's quite interesting. So I often give courses at banks and insurance companies, and they're paranoid beyond belief. Right? Trying to get anything installed is near impossible. And they say, we can't possibly install an R package, it's just not allowed. So you take them through the little steps of, are you allowed to view a web page? Yes. Are you allowed to look at the source of that web page? Yes. Are you allowed to copy and paste it? Yes. An R package is just a collection of R scripts. Right? There's nothing particularly inherent and stable about it, it's just R code. So it's basically an R package is a zip file with a directory called R, it's nicely named, and that contains some functions. Okay, this is a bunch of functions. It's got a directory called man for documentation. Okay. It's got an optional directory called data for data sets. It's got a directory called inst, which is basically just for a dumping ground for everything else, but you typically find C, Fortran, JavaScript code, that sort of stuff in here. And then it's got 2 important files, right? And it's got a file called namespace and a file called description. Right? And it's plain text. So if you're interested in what's inside an R package, download it, unzip it, and you can just look. Right? A good way of learning of how to get better at R is to find a package author who you think is really good, and then learn from them. Unzip the package and look at the code. How did they write it? It's a really good way of learning. And so the namespace file, that's just a collection of essentially functions that you're allowed to use from that package. Okay? And the description file contains bits and pieces like the name of the package, a little blog about the package, but it also contains some stuff on what packages are being imported, what are the dependencies of that package. So I'm developing this package X, and it needs Y and Z to be run. Okay? And in 2.14, so that's a while ago now, sort of 6, 7 years ago, I introduced something called namespaces. Right? So this is me sort of veering a little bit off CRAN. So now 2.14 introduced something called namespaces. So what on earth is a namespace when it's at home? Well, as all good lecturers say, there's a great definition of right spaces for names. There you go, that's a good definition. And they give an object context. Right? So essentially when we're in R and we say, can we get the function f, or can we get the object x, the namespace allows us to give it a bit more context of, can we get the function x from here? Can we get the function f from there? Can we get the function z from over here? They provide a context for each of these objects. And it allows us to have the same name, but it exists in multiple different places. Yeah. So for example, so the stats package is one of these packages that comes with R. Right? So you use the stats package all the time. When you load R, it's automatically loaded. Right? It's automatically there. That's where LM lives, the linear model function. And it's got a function called filter inside here. Okay? And that applies a linear filtering to time series. So it's been in R for forever. And it's loaded. So you type filter, you'll get that. So if you are one of the cool kids, you'll be using this package called dplyr, and that's also got a function called filter. Right? And that's used for manipulating data frames. So we've now got a bit of trouble. Right? We've got filter over here, which is where the traditionalists would say it's for filtering time series. And then we've got this thing here that manipulates data frames. And we can access whichever function we want directly. Right? So this double colon, so a single colon operator in R is used for generating a sequence of integers. So 1 colon 5, 1, 2, 3, 4, 5. The double colon operator allows us to access a function within a package. Right? So here we're using the double colon and say, we want the function filter from the stats package, or we want the function filter from dplyr. Right? So we can be incredibly explicit of which thing we want. But perhaps more interesting is, well, what if we just type filter? Well, you know, I'm sitting there and I type filter. Which function do I access? Right? Do I access the one at the top, or do I access dplyr's version? Right? There's two versions, which one do we get? And the way R resolves this is it looks at the last package that's been attached. Okay? So if you type search in your R console, which I always think is a really bad name, but there you go. If you type search in your R console, you get a list of packages, or a list of namespaces that have been attached. So here on the very first element, we've got the global environment. So when you start R, you come up with a big box, a big environment where you put stuff. And then you've got all the other packages that have been attached in order. Right? So number 2 in that list is dplyr. That's the package that attached a second ago. Then I've got ggplot2, then stats, then graphics, then GR devices, all the way down. It uses that one. If it doesn't find a function, it goes on to dplyr. It looks at a function called filter in dplyr. If it doesn't find that function, it goes on all the way down until it finally runs out of stuff, and then you get an error saying object not found. So namespaces are really, really important, really useful. They allow us to have the same named object. And to be fair to dplyr, it does actually give you a clue that this is happening. So when you load a package and you're getting these sorts of messages, the following objects are masked from package stats, that's telling you you've got this function with the same name. Right? So in stats we've got filter and lag, but in dplyr we've also got functions called filter and lag, and it's giving you a warning. And in case you've ever wondered, which of course you must have, that's why wouldn't you? If you look at the function definition for SD, so the function definition for SD just does what you'd expect. It calls the square root of the variance function. Right? You know, so SD, function for calculating standard deviation. How does it work? It essentially just takes the square root of the variance. Well, what would happen if you were just a bit stupid and redefined the variance? Right? You know, does everything now just sort of break, and people around the room now thinking, oh dear, have I done this before? Never done, bar variance, it's all getting a bit Well, don't worry, I've done the correct thing. Everything still works like magic. And it works like magic because of the namespaces. Right? So this function SD is in the stats namespace. So when it looks for the function var, it looks inside its own namespace first before going down that tree. Okay? So namespace takes care of all this sort of horribleness that we just don't need to worry about. And in case you're wondering, which, well, probably not, I've got no concept of private. Right? So you've got the single colon operator for doing integers, you've got the double colon for accessing functions exported by a package, and then you've got this treble colon operator that you can use to access functions that people are trying to keep a bit hidden. Right? So in the ggplot package, there's a function called absolute grob. I've no idea what that does. It sounds quite cool now if I think about it. And that's not exported, i.e. the package author has just said, you know, this is my function, you lot aren't allowed to use it. But now we can't keep anything private, so you can access it using the 3 colons. As I said, I'll be completely off course with the whole CRAN 20 years, but we are going back to CRAN, so don't worry. So, when I was thinking about what to put in this talk, it sort of struck me as you've got CRAN, you've got 10,000 packages, but they're not 10,000 individual packages. They don't exist in a little bubble by themselves. Right? They've got lots of complex dependencies between them all. Right? It's not 10,000 independent things, it's 10,000 packages, each with connections going. And you can imagine drawing lots of arrows between these packages. Okay? And in the file, in a package file, you've got this thing called description. Right? And it's got a bunch of labels that tells us what dependencies that has with other packages. So it's got an element called depends. Right? And that's strongly discouraged. So that was their sort of pre-R2 14.4 namespaces came along. Okay? So you're not really meant to use depends. It's sort of kicking about just because it takes things to catch up. And what depends does is if you depend on another package, it adds that package to your namespace search path. Right? So if you put a package inside depends and load that package, when you type search, you've got extra things going there, which is not very nice. What you're meant to do is use something called imports. Right? So imports, again, you just got a plain text file, you've got an element called imports, and then you're just listing my package needs this, this, and this. Okay? And it does include the search path, if that's the correct way. I don't know if you've ever thought about this, but when you install a package, things just work, right? Most of the time. You know, you do install.packages. If you do install.packages dplyr, it goes away and gets a whole host of things and just installs it, and then just works most of the time. And that's pretty impressive. And it's because when you install a package, R looks at the imports and then looks at depends, and then gets those additional packages if they're needed. Have you ever used Python? Messing about with packages in Python is a pain in the rear end, yeah? Python's nice, but packages are painful. You've got something called suggest. So suggest a package is not required in the standard package workflow. And you typically list things there for testing, perhaps advanced plotting, just sort of bells and whistles. So they're not really needed for everyday use, but they're there just to make things a bit better. Okay? You've got this thing here called enhances, which is very bizarre. So this is packages listed here enhanced by your package. So 99% of packages have 0 enhancements, because no one's really quite sure what it means. The record for the most enhancing package, I don't know if Philip is here, he's from Glasgow Uni, so you've got a local star somewhere nearby who has the most enhancing package ever with 37 enhancements. So congratulations, Philip. So these are all the different ways the packages can depend on each other. Right? And what you can do, sorry, soft forgot what's coming next. So we'll go back to CRAN and then come back to this. So what is CRAN? So CRAN's a package gatekeeper, right? So I don't know, for those people who've got a package in CRAN, how many have had how do you phrase this? An interesting response back to make you just think through your life choices. So CRAN's a package gatekeeper, and it sort of, you know, basically helps the users. You know, it puts a lot of people in CRAN put a lot of time and effort to make sure packages a bunch of specifications. And it sort of tries to keep out, as much, I think I'll just stop there. It tries to keep out packages that shouldn't be there. We'll just go for that. So in order to get a package on CRAN, some of the CRAN checks, and there's sort of dozens of these things, a lot of them are automated, but some of them that actually requires a human being to look at them. So it checks that all functions exported have good documentation. Would you believe you can't enforce good documentation? You can only enforce a package with good documentation. And some packages make really creative use of aliases. So there you've done question mark function, and you come up with a help page, and you've got all 20 functions in that particular package listed there, because they've been forced to write documentation, so they just write any old rubbish. It checks for poorly written code. Right? So again, you probably never thought of it, but there's a function called system in R that you can start messing about with your file system. CRAN stops people using that for packages. When you install them, you're not going to get someone saying, delete all files in my documents, for example. Right? There's checks for that sort of stuff. Ensures that examples work. So all the examples at the end of the help file, all those examples are run on CRAN's machines under Windows, Linux and Mac. Right? It's a huge computational problem. It makes sure you can install a package under all these operating systems. There's also something called Solaris, which is the pain of most people's life, because no one's got access to a Solaris box. So the worst thing is you send a package to CRAN, and you get a message back saying it doesn't build under Solaris, and you think, I have no idea what this means, because you have no access to this box. But it works under Solaris. Some of the downsides, it constricts the amount of time required to run unit tests. Right? So when you have a package, you can have unit tests to check that things work, but because they've got 10,000 packages, they make that there's a time limit. Things run about 60 seconds. Okay, so it's not great. It checks things like the formatting of the description file. So does the email address work? You put a URL, does the URL actually resolve, or does it give you a 404? Again, there's more details in the manual. So volunteers spend a huge amount of time communicating to package authors. Right? So I think it's a couple of packages every day, not just being, you've got 10,000 packages, but those things are constantly being updated. Right? And it requires a human being to email and communicate with people when they update packages. If something breaks, someone's emailing that package author back saying, your package is broken, have a look at this. Right? So there's a huge amount of people spending time and effort building this infrastructure, and then sort of the timely part is responding to package authors. And many, or perhaps the vast majority of package authors aren't programmers by nature. Right? The statisticians, biologists, geneticists, whatever. We don't have a formal programming background. We did some sort of ropey undergraduate course in R. We did a PhD. Your supervisor thought it would be a good idea to put in a package, not that they really know what that is, but they think it's a good idea, and then off it goes. And it's a huge amount of time. And the other thing that CRAN does is it runs checks of all the R packages with every single nightly build of R. Right? So R is getting changed and updated all the time, and then every single night, that new version of R is run against all 10,000 packages. So it's got a really good test suite. You've got 10,000 packages with unit tests and everything else. And this takes 90 days of compute time, right, to do this one check. Also, it's running parallel, otherwise things get a bit silly. But every night, the new version of R development is running against all these R packages. So how do you get a package on CRAN? So the greatest victory is that which requires no battle. I think that someone's getting a package on CRAN. I have to admit, now when I put a package in CRAN, it's still quite nerve-wracking of, am I going to get, yes. I'm not going to say it because I'm getting recorded. So, how do you get a package in R? Well, all packages must have documentation. Right? You have a function, you're saying to people, use my function, you should provide documentation. One of the things that R checks is that your documentation is correctly formatted. And writing documentation is awful, right? No one likes writing documentation. It's just I don't. So ROxygen 2, it's a package called ROxygen 2, allows you to have in-source documentation. Right? So in R, you have the hash symbol for a comment. Right? And if you notice here, I've got hash, dash, and then at. And you've got these little bits of comments just above your function. Okay? And so when you build your package, those comments automatically generate the corresponding documentation page. So you don't have to try and maintain two separate files, which is a real pain in the rear end. You just have one file, you've got your function, and then just above it, you've got a couple of lines telling you the title of your help page, the description of the help page, the parameters. But the crucial thing is you've got your documentation next to your function, and that just helps you. And it takes some of the pain away from documentation. Use a test suite. Okay? So again, I suspect most people here are programmers by training. So in programming, you get taught, you should have a test suite. Well, as statisticians, we just don't. We just sort of hope for the best and go for it. So you can create a test suite, and that could be something really simple. It's basically just a bunch of functions saying, if I run this function with these arguments, this is the output that I get. Right? Simple as that. And it just stops itself shooting yourself in the foot. Right? You make a change, you run the test suites, does everything still pass? Right? Quite easy. Use continuous integration. Right? So this is getting a bit more advanced. So continuous integration. So that's an idea that when you make a change, a computer automatically takes your new package and runs a bunch of tests automatically without you having to do anything. Right? So without you having to say, go away and check, it just happens. It's continuous. Whenever you make a change, all this stuff happens. So this is assuming, for example, your package is something like GitHub, right, or RForge. And so what happens is you make a change to GitHub, you push a commit, you make an alteration to a file. These things here, Travis and AppWare, are sort of monitoring your repository, your code continuously. When they detect a change, they automatically spring into action and run a bunch of checks. Right? So when I make a change to one of my packages, it automatically tries to build a package under rpast, rrelease, rdevelopment. Right? Without me doing anything, I've just made a change, it just does it. It tries to run the test suite and make sure they all pass. It builds any vignettes, any sort of documentation I've got. It runs rcommand checks, and the idea is we're detecting errors early. If everything passes, you don't hear anything from them. If one of these things fail, you get an email saying it's all gone badly, right? And you go over and fix it. And it also makes it easier to incorporate changes from other users. You have someone really keen, they say, would you like to add this function in? And you think, well, why not? Well, here you've now got a nice systematic way of figuring out, does their new amazing function break things without you having to do anything? Okay? So it's a really nice way. There's also something called EraHub, and that looks really promising. So it's developed by the R Consortium, and it's still sort of the developmental stage. It's usable, but it's still a bit rough around the edges, but it's looking really good. So these are the current platforms that it supports. So it's got lots of flavours of Windows and Ubuntu and Debian. And so what you can do is you've got your package and you can say, would you mind checking my package on Windows 64-bit release candidate? And that will fire up your package, run it on a Windows box, make sure it passes all the checks, and you come back saying, great. So another nice system. Right? Packages have got these huge dependencies going on. And if you look at the sort of the imports and depends, so here on the y-axis we've got frequency of packages, and then on the x-axis we've got the number of dependencies in a particular package. Right? So there's around about 1,000 packages with no dependencies whatsoever. Then most packages have at least one dependency, so around about 1,700 of one dependency. We've got a package all the way down the bottom right-hand corner with 37 dependencies. So it's sort of a beast, it's a bioconductor, so it's genomic stuff. But packages don't live in isolation. Right? We had that description file, we had import, suggest, dependencies, lots of dependencies. And you can build yourself a little diagram, a little graph. Okay? And so here's a package called DRAT. We'll come to what that package does later on. And all the arrows are just sort of listing the dependencies. Right? So the purple arrows, DRAT is the big thing in orange, the purple arrows are suggests, and then those suggested packages also have dependencies, and those dependencies also have dependencies, and so you get this network structure. Okay? So it's, it's quite nice. And you'll start seeing there's RCPP right up the top. So even though DRAP doesn't actually use that package directly, because you're going down this graph structure, it will eventually use it. There's Markdown, there's one there. There's Markdown, a few packages that you're probably not familiar with. There's sort of the building blocks. But you get this graph structure. And so what you can think of is, well, what would happen if we did this with all CRAN packages? Right? So this circle contains allegedly 10,000 points. I don't quite believe it, but that's alleged. I think there's a few overlapping. Right, so these points represent all the points in CRAN. Right? Each point is a package. Okay? And what would happen if we drew arrows between packages with dependencies and imports? Okay? Well, what happens is you just get a big mess, but that's you live in that. So that's not particularly useful, that. So let's take a step back. Right? Can we detect clusters of packages? Right? So I'm borrowing this sort of idea from Andre, who works at Microsoft. And again, there's a link to his original presentation. And we're using this function, this iGraph function. So iGraph's a package that's really good for working with these sort of network diagrams. And there's a walk trap algorithm that just tries to find sort of small clusters within this package. So we've got this sort of hairball mess. And when we look at this walk graph, we sort of start seeing different clusters. Right? So the colours are what different packages have been clustered as. So here we've got a big mass of blue points. That's the MES, that's the regression package, I think. Random numbers. We've got RCPP in the bottom right-hand corner. We've got the famous ggplot2, it's sort of the green star system. SP is spatial, so we've got a sort of spatial part in the left-hand corner. And HTTR, that's stuff for doing sort of webby technology. Okay. So you start seeing sort of main clusters, which is quite neat. Think of the package authors, right? So RCPP and ggplot2 now have a huge number of reverse dependencies. Right? So if you're that package author, if you're Hadley or Dirk, you now have this package that you've got hundreds, if not thousands, of people are now depending on. So every time you make a change to your package, you now need to check, have I broken someone else's code? Right? So it's not just CRAN. These sort of huge hubs of packages are now sort of also experience the pain/pleasure of being popular. Right? So you make a change to ggplot2, you need to check 1,000 other packages to make sure nothing's broken. If it has broken, you need to email the package author and say, look, I've changed it, it's broken. This is what's going on. Right? It's a huge amount of time. Here's an interesting question. What happens if a package is wrong? Right? So again, whenever I give courses at businesses, you get this idea of, but how can you trust R? Why can you trust R? It's just some random person. And then you ask them, when was the last time you got a refund from Microsoft for your machine crashing? And no one's ever came back with an answer for that question. But this is a serious question of what happens if a package is wrong? So, I don't know if this is a famous or infamous package, the school math package, and it does functions and data sets for school mathematics, right? So pretty straightforward, simple stuff, nothing complex. So it's got sort of simple prime number algorithms. And there's two versions, released within 24 hours of each other. So you can imagine that they've got it on CRAN, and then they've got another email saying things aren't quite right, please fix. And it passes all CRAN checks. So all the checks I mentioned, it passes. Right? So it's got documentation, it builds in all the systems, it passes whatever it needs to pass. But there's some of the functions that are just wrong. Right? There's not an argument of, well, actually, they might be right. You've got a function for detecting prime numbers, and it misses out some prime numbers. Right? It's not big prime numbers, we're talking small ones. School mathematics. So who's in charge of removing that package? People have tried emailing the author. The author's not responding. The package went on in 2007. So there's sort of not an easy answer of who's in charge of taking up a package that's wrong. So just say the package is still there, but it does raise sort of interesting, difficult questions of how is this stuff going to be managed? Right? And again, take a step back of, if you imagine 40 years ago when you had CRAN and the person in charge of CRAN was a frequentist, would you get any Bayesian packages on? Or, it's sort of hard trying to sort of take away bias from people. You know, so just now all package checks are very machine-led. Do we need to use CRAN? It's a controversial question. Could we possibly go away with CRAN? Well, yes, we can create our own repository. So all CRAN is just a package repository. A package repository is just a website with a specified structure. And this package strat makes it really, really easy to create your own package repository. So you don't even need to go away and read out what the URL structure is. You can do it yourself. So this package strat makes it easy to create and maintain repositories. If you use GitHub, GitHub automatically provides web pages for free. So you can host your own repository on GitHub free of charge. You can put your repository there, and it's now got version control for free. So how do you create your own repository? We run one function init repo, and that initializes a repository structure. So it just initializes a directory with the correct paths going in it. You know, so there's a little bit over here for Windows, a little bit over here for Mac, a little bit over here for Linux. You can add to the repository. So if you do insert package ABC, it automatically puts it into the right place and updates the right files, and you don't need to worry about what's happening. And we can now install packages using the usual sort of song and dance routine that we're all familiar with. We can do install.packages ABC. All we need to do is just specify which repository we're using. Because we're not using CRAN, we're going to be using something else. So you can do this either on an external web server, or if you're a paranoid bank, you can do it in your internal file system. So, you know, again, at Newcastle we have internal packages, and we just have them on an internal file drive. It's not because they're particularly secret, it's just that no one's interested in them, so, you know, for marking scripts. So when I do courses, each course I have its own package. Package is a wonderful way of just putting together all your data sets, all your vignettes, all your documentation, all your solutions. We don't want to bother CRAN. I suppose it should come clean and says I did bother CRAN a few years ago, and they told me to get lost. So we don't bother CRAN at all, and packages are of limited interest. We're in complete control. They're hosted on GitHub, and they're all hooked up to this Charis, and this continuous integration. So what happens is we've got a package on GitHub. I make a change to the documentation, or I make a change to some of the functions. Charis runs through all the checks, makes sure it builds, and then if it builds, it then pushes that package onto the repository. So it's a really nice way of just managing this stuff. So do it for undergraduate teaching, do it for consultancy courses, which is great. There's another package called MiniCran, and MiniCran's used to get all the dependencies. So remember the graph that I showed you with all the dependencies? That MiniCran did that for me. So what you can do is you can do a MiniCran, and then you can download all the packages that you need, put it in a USB stick, and now you've got CRAN in a stick. You don't have all 10,000, you've just got the bits that you need. So again, that's a really nice way if you're doing teaching, you know, you're going to another university, you're not quite sure of the Wi-Fi, it's a bit ropey, put CRAN in the stick, and then you've always got a backup. It's quite a nice way of doing it. But CRAN does provide trust. Right? You know, so this is great for my courses, and people just trust me, but in general, CRAN does provide a sort of a stamp. And I quite like this little pyramid graph that I found. So it's Bob Ruddis, I think that's how you pronounce his surname. And it's, you know, how do you know which package to trust? Right? Would you believe that some nasty people on the internet that don't tell the whole truth all the time? And here's this idea of, well, at the top, the thing you trust the most is the stuff that you did, which may or may not be a good idea, but that's the stuff you trust the most. And then you've got CRAN and Bioconductor, right? That's sort of pretty good. Then you've got sort of private GitHub repos, right? So, you know, perhaps you're part of an organization that's got a private GitHub repo. Then you might have public GitHub repo, but you know the person who wrote that code, right? So you're installing code from ggplot2, but the developmental version, you know, so you sort of know who the author is, you trust that person. Then you've got sort of random GitHub repos kicking about, and then you've now got random author website right at the bottom. And I think as R gets more and more popular, we're going to start seeing people doing slightly more nasty things. Right? You know, just now we install packages, we don't really care, it just sort of works. And we just sort of copy and paste random R code, and it just sort of works. But as sort of the user base increases, things are going to become more and more sensitive. Especially as people start using Shiny. You know, you're now putting R code on a web server. Well, there's lots of bad things people do to web servers. Right? So we need to start thinking about how to install this stuff. So, summary. One of the reasons R has been a success is due to CRAN. Right? You know, it's just an amazing resource. 10,000 packages, lots and lots of people checking those packages, maintaining the infrastructure. You know, just think of the infrastructure needed to host 10,000 packages and all archived versions, and then mirror all around the world. There's a lot of stuff going on, right? It just works. You know, it's still great. And will CRAN be able to keep up as it is? Perhaps. You know, you can sort of see 10,000 is now a big number. And don't know, is that classed as big data? Does big data be more sexy? But it's getting a big number. And you can start seeing, well, perhaps I might want sort of a package, you know, a repository over here that's just sort of core tidyverse packages, for example, and perhaps splintering off. But who knows? So thank you very much, and do you have any questions?
Okay, so I think we just about have time for one or two questions, if anyone has any. Are there any?
One question from Michael Bob. With more than 10,000 packages on CRAN, how to find the one you need?
How to find the one you need? So the unknown unknowns, which I'm going to say. So, personally, you just need to keep involved. So there's lots of things like, so if you're on Twitter, there's a feed that tweets the latest packages that are added. You know, so every day you get the next 2 or 3 packages, and so you've got the titles, you've got the description, and you get a rough idea of what's going on. There's reading blogs, is always a good way, or at least skimming the title. You know, so personally, I just spend a few minutes each day looking at our bloggers, seeing if there's any sensible packages out there that I want to investigate more.
An answer being posted by Alberto Caimo. It says, yes, fantastic. And the R package SOS.
Yeah, so I've never used SOS. Yeah. Yeah. Yes. Yep.
You mentioned that before R there was S or S plus.
Yeah.
What was the reason for the change?
So this is me trying to remember a talk from last year. So this may or may not be strictly correct. So S started in AT&T labs over in the States around about 1970 odd, and S got really popular because it was essentially packaged up with Unix. So as Unix went around the universities, S came free of charge, and then AT&T labs thought, oh, we could make some money, and at that point thought, well, there's a sort of fork. And so there's actually a function in R called is.r to check if you're actually running R. It's an interesting thing. So you can check if you're running R when you get home at night by typing is.r. So again, around about 2000, they're really worried about, can we use original S code in R? Now, no one really cares.
Okay.